Hello once again. Today we're going to talk about the nomenclature of the organic compound of alkane. Particularly, we're going to focus on the prefix. In our last video, we talked about the word root and primary suffix. So let's talk about the prefix here. So let's take a look at the compound here as a methane, carbon with the 4 hydrogens. If you break one of the carbon-hydrogen bonds, the remaining CS3 group, we consider this as the alkyl group. So methane becomes a methyl group. And if this methyl group is present in a long carbon chain of a compound, we consider it as a substituent or prefixes. So here, the prefix of the compound, the IUPAC name of this compound would be methyl. So the name of this compound would be 1, 2, 3, 4, 5 pentane, carbon-carbon single bond, right? From the third carbon, there's a CS3 group is projecting, so the name of the compound is 3-methylpentane. Let's take a look at another compound, ethane. If we break one of the carbon-hydrogen bond from the ethane, as shown by the squiggle line here, the remaining CS3 and CS2 group is now called ethyl group. So methane to methyl, ethane to ethyl. So if this ethyl group is present in the long carbon chain of a compound, within a compound, we consider this as the prefix. So this group, ethyl, is present and be joined at the third carbon atom, right? So that's why the name of this compound will be 3-ethyl, 5 carbon containing pent, and it's a carbon-carbon single bond ane. So 3-ethylpentane. Likewise, in the case of the propane, you have 2 CS3 terminal and the internal CS2. If you break one of the carbon hydrogen from the terminal carbon atom, as shown here, squiggle line, the remaining CS3, CS2, and CS2 group is considered as the propyl group. If this is present as a substituent in the long carbon chain containing compound, the name, we consider this as the prefix. The name of this compound, since there's an 8 carbon, is an oct carbon-carbon single bond is an ane. So the name of this compound will be 4-propyl octane. Likewise, now if you break a carbon-hydrogen bond from the internal carbon atom, the remaining CS3, CH, and CS3 group, we call it as an isopropyl group. If this isopropyl group is present as a substituent in a long carbon chain of a compound, we call it a 4-isopropyl octane. Likewise, let's take a look at the butane to butyl, similar to propane to propyl, right? Here, if you break the carbon hydrogen from the terminal CS3, it doesn't matter whether it's a right CS3 or the left CS3, you'll end up getting a butyl group. Here, if this butyl group is present as a substituent and is projecting from the carbon number 5, its locant is in the 5th position. So the name of this compound is a long carbon chain is a 10, so the dic, and then carbon-carbon single bond is an ane. From the 5 position is a butyl group is projecting, so the name of this compound is a 5-butyl decane. How about if you break the carbon-hydrogen bond from the middle carbon atom? Doesn't matter whether left CS or the right CS here. If you break this bond, the remaining group we call it as a secondary butyl group. Why? Because the carbon where the carbon-hydrogen bond is broken is attached to the 2 carbon, 1 carbon, 2 carbon. So this is the secondary carbon. So if this secondary butyl group is sticky as a substituent in a long carbon chain containing molecule, we consider this as the prefix. So the name of this compound would be 5-secondary butyl nonane. This 5-secondary butyl group is the prefix here. Now remember that the N-butane can be rearranged in a different way, and that will result into the isobutane. So in the case of the isobutane, you have about 1 internal carbon hydrogen bond is there, and there is a CS3, CS3, so there's a 3 CS3s are there. So these are all terminals. So if we break one of the carbon-hydrogen bond from this isobutane, the remaining group is now called the isobutyl group, and it is denoted by the symbol I. If this isobutyl group is present in the long carbon chain as shown here, from the fifth position, that would be 5-isobutyl, since the carbon is a 9 here, non and carbon-carbon single bonds are ane, so 5-isobutyl nonane is the IUPAC name of this compound. How about in the case of if you break the carbon hydrogen from the internal carbon atom? If you break this, the remaining group is called a tertiary butyl. Why? Because the carbon that is, we have broken the carbon hydrogen is attached to 1 carbon, 2 carbon, and 3 carbon. So that is the tertiary butyl carbon here, which is projecting as a substituent in a long carbon chain. So that is a 9 carbon containing molecule, so nonane. And this group is a tertiary butyl projecting from the fifth carbon. So the locant is the fifth. So the 5 tertiary butyl nonane. So what's going to happen if it's the 5 carbon containing compound? If you break the carbon hydrogen from the terminal, it will be N-pentyl. So likewise, secondary pentyl, isopentyl, tertiary pentyl, neopentyl, and so on and so forth. But whenever there's a multiple substituent is present, right, they have a different arrangement, and then now we might end up getting into a trouble or give this some kind of a different name. So the better way of doing that is to, in order to discern this type of like perplexity, the IUPAC nomenclature has given some kind of a rule where the substituent itself can be treated as as a single entity. As for example here, the longest carbon atom is the oct and carbon-carbon single bond, that is octane. But now if you take a look at this substituent over here, you have the carbon directly attached to the word root. This is the number 1, which is always given number 1, which is attached to the word root. So there's a longest carbon chain within this entity. It will be 1, 2 carbon here. So that's the ethane. So from the first position of the ethane, there is a methyl group. So this is like, 1-methyl ethane, right? So now this group is present as a substituent overall within this particular compound, octane. So now it is considered as a 1-propyl ethyl group. So the name of this compound would be 4,1-methyl ethyl and then octane. Let's take a look at this branch compound over here, branch substituent here. In this case, again, the locant of this substituent is at the 5th position. We know that. That's why it's a 5 here. But the carbon directly attached to the word root is number 1. So the longest carbon chain would be 1, 2, 3. So it's a propane. From the first carbon, there is a methyl group is projecting. So the name of this substituent will be 1-methylpropane. So this 1-methylpropane is as a substituent, present as a substituent of a long carbon chain, 9 carbon containing molecule. So the name of the name of this substituent will be 1-methylpropyl. So the name of the overall compound is 5,1-methylpropyl nonane. How about here? In this case, again, the carbon directly attached to the word root is the number 1 here. So the longest carbon chain would be 1, 2, 3. From the second carbon, there is a methyl group is present. So the name of this substituent would be 2-methylpropyl. And this 2-methylpropane is present as a substituent of a long carbon chain here. That's why we consider it as a 2-methylpropyl group. So the locant is 5th position. In the 5th position, there is a 2-methylpropyl group is present, and the longest carbon chain is a 9, so the nonane is there. How about in this case? Here also, the locant is 5. The first carbon that is directly attached to the word root is number 1. There's a number 2. So this is the ethane. And from the first carbon atom, there is a 2-methyl group is projecting. So the name of this substituent would be 1,1-dimethyl ethane. Since this entire entirety is present as the substituent of a long 9-carbon containing molecule, the name of this molecule would be 5,1,1-dimethyl ethyl nonane. All right, now let's take a look at the IUPAC name of some multi-substituent containing molecules. When you have a multiple substituent present in the compound, you always make sure that give a higher priority to the low locant. Locant means the position of the substituent. For example, between these two compounds, the methyl is in the second locant, this methyl is the locant 7th, second and 7th. If you consider the one from right to left here, numbering, the methyl on the 3rd, methyl on the 8th. So 2,7 versus 3,8, the one in the left wins. So this is the correct and this is incorrect. So the name of this compound would be 2,7,2,7-dimethyl. Two methyls are there. 9-carbon containing non, and ane is the carbon-carbon single bond. When two substituents are present at the same location, if you consider numbering from left to right versus right to left, as for example here, under that circumstances, we consider the alphabet. So now you can see here the methyl on the 3rd versus 3rd and the ethyl on the 7th. Here, ethyl on the 3rd and the methyl on the 7th, right? So which one is correct? So again, if you start from the numbering from the left, this is 3rd. If you're from the right to left, this is 3rd. So there's a tie, 3-7, 3-7. Now we consider the alphabet. So ethyl presides over methyl. So we give a priority to the ethyl. So the name of this compound would be 3-ethyl, 7-methyl, 9 non, carbon-carbon single bond ane, nonane. Take a look at the one at the bottom. Longest carbon chain is 10. Substituent ethyl, propyl, and methyl. Locant is 3rd, 5th, and 7th. Now, whenever you write down, make sure you follow the alphabetic rule, right? So 3-ethyl, 7-methyl, 5-propyl. E, right? And MNOP. So M comes before the P. So M and P. Take a look at this compound. In this case, you have a chlorine and then fluorine as a substituent. So we give a chlorine becomes chloro, fluorine becomes fluoro, right? So here, 2 and 6, here also 2 and 6. If you go from left to right, right to left. Under this circumstance, there's a tie here. So we follow alphabetic order. We give a priority to the chlorine over the fluorine. So the name of this compound will be 2-chloro-6-fluoroheptane. Here's another compound. You can start numbering the longest carbon chain, right? From left to right versus right to left. So now the iodine, and then methyl is there. So iodine is now considered as the iodo, and then methyl group. So we give a priority to which one? We give a priority to the alphabetic one, right? So whichever comes first. So here, I comes before the M, so the one in the left is correct. So the name of this compound would be 2-iodo. Now there's a 2 methyl groups. Remember that. There's a 1 in the 4th group, 4th carbon, and then another one in the 6th carbon. So 4,6-dimethyl heptane, because the longest carbon chain is 7 carbon containing. One important thing you need to understand here is that whenever there's an alkane and halogens are present, we always treat them equally. Okay, but whenever there's a tie, we always follow the alphabetical order. Let's take a look at this compound at the bottom. In this compound, you can see that the compound, you can number from left to right because chlorine is C, methyl is M. So the longest carbon chain atom is a 7, which is the heptane. Second position is a chlorine. Fourth position is methyl. And on the 4th position, we do have an ethyl group. So A, B, C, D, E. So C, and then E, and then M. So the 2-chloro, 4-ethyl, 6-methyl and heptane. So that's how we name it. Let's take a look at this one, a little bit of complex structure, but again, we follow the same rule, left to right and right to left if you number it, right? So let's look at the locand. What is the locand here? From the left to right, the methyl substituent in the second position. From right to left, the methyl substituent in the third. So we give a priority to which one? One in the left-hand side. So this is correct. This is not correct. So now when we name it, there are methyl versus ethyl. So we give a priority to the ethyl. So that's why it's a 3-ethyl, 2, 4, 5, 6. Tetramethyl, longest carbon chain is 8, so octane here. So the name of this compound is 3-ethyl 2,4,5,6 tetramethyl octane. So one thing you need to understand here is that so whenever there is a 2 substituent is present, we give a prefix di. 3 is the tri, 4 is the tetra, penta, hexa, and so on and so forth. So this is how whenever there is a multiple substituents present in the molecule, we give a priority based on the locand versus the alphabetic order. Now let's see some more branch substituent containing compounds. Let's take a look at these two compounds. It's the same structure. Now if you start numbering from left to right versus top to right, you see the number of carbon is 8. There's a tie. So which one is correct? So based on the IUPAC system, we give a priority to the carbon chain when we're numbering that contains greater substituents number, right? So if you consider here in the left-hand structure, there is only one substituent in the third position, whereas if you consider from the top to the right, you have a 2 substituent in the second and the third. So based on the system, IUPAC system, the numbering right hand side is correct. So the name of this molecule would be 3-ethyl 2-methyl octane. So 3-ethyl 2-methyl octane. Let's take a look at a little bit larger structure. Here, if you start numbering from left to right, there's a 12 carbon. Here, from the top to the right is 11. Here, from top to the left is 10 carbon. So based on the IUPAC system, IUPAC rule, we consider the longest carbon atoms. So 12 carbon atom is the correct numbering, whereas these two in the right-hand sides are not correct numbering. So what is the name of this compound? So remember that earlier I talked about whenever you have a branch system, we consider this as a single entity. So here you have longest carbon atom, which is 12 carbon, which is a dodecane. From the 6 locand, there is some kind of a substituent, branch substituent is present, as shown here. So the carbon that directly attaches to the main chain is the number 1, number 2, 3, 4. So the second position within the branch has a branch. So this second position is a 2-methyl, a long carbon chain is a butane. So 2-methyl-butane becomes 2-methyl-butyl. So here the block is now can be substituted with 6,2-methyl-butyl dodecane. Let's take a look at this structure. I hope you can name this structure now. You know that there is a dodecane. At the same time, third position there is a methyl. Sixth position there is a branch substituent. So carbon number 1, 2, 3, that's the propane. Carbon number 2 has a methyl, so 2,2-dimethyl-propyl, right? So what is the name of this compound now? 3-methyl 6,2,2-dimethyl-propyl dodecane. Let's take a look at another structure. Again, the longest carbon atom is 12. We have a branch substituent in the 6th position. This is the carbon number 1, 2, 3, 4. From the 3rd carbon, there is a methyl. So 3-methyl-butyl group is present on the 6th carbon. So the name of this compound is 6,3-methyl-butyl-dodecane. Let's take a look at another compound. 6th position again, we have a branch substituent. 1, 2, 3. This is the propane. From the 2nd position, there is a dimethyl. So that is 2,2-dimethyl-propyl. So that means the name of this compound is 6,2,2-dimethyl-propyl-dodecane. Let's take a look at the final molecule in this set. We have again 12 carbon containing chain. 3rd position we have an ethyl. 10 locant to the methyl in the 10th locant. Whereas in the 6th position you have a branch system. Again from the branch 1, 2, 3, 4 butyl. So 3-methyl-butyl group is present. So the name of this compound would be 6,3-methyl-butyl, which is this guy, 3-methyl-butyl. And the 3rd position you have a ethyl, and the 10th position you have a methyl, and the longest carbon is a 12, so this is a dodecane. I hope I have given a good example for you to understand how you give the IUPAC name of the alkanes. I'll bring you some more examples of the cyclic system, cycloalkanes, and some more videos regarding the IUPAC name and some other organic chemistry related, some interesting things. Thank you.